know how to graph using the three forms, right? We have, or like when you get to the second one, that gets kind of hard to graph. So if I look at this, what I've left this middle column for is to plug in the value of x to figure out what y is, right? So I know I have -2 times x here is -2 plus 1. So I just want to evaluate that, right? So -2 times -2 give me 4. 4 plus 1 would give me 5. So my kind of coordinate point would be -2, 5. Right, so I could keep that going and say, well, what happens if I plug in -1? So if I do -2 times -1, I get 2. 2 plus 1 is 3. So my point here, -1, 3. So I can keep that going, right? So you guys figure out the rest. I'll work on them up here. I want you to work through the next couple. Okay. Anybody get what it would be for 0? 1. Right? -2 times 0 is 0. And I put 0, 1. How about for 1? What? -3, yeah. 0, -3. No. Close. -1. Yeah, because I want to go -2 times 1 is -2. -2 plus 1 would give me more positive, so that's 0, -1. So, Brendan, what'd you get for 2? The last one. -3. That's where I got -3. What just happened? So, this one, I would get -3, right? So, and that should have been a 1. 2, -3. So when I want to graph these, when I look at the graph, remember that this is my x coordinate, my x axis over here, the horizontal one, and my y is this one. So when I graph, I go with this idea of I have x, y here, so I'm going to do x first, then y. All right, so if I look at each of these points, -2, I'm going to go over -2. So I'm going to go over 1, 2. Then I'm going to go up 1, 2, 3, 4, 5. Right? And I'm going to make a point there. So make my point. I'm going to keep doing that, right? So -1, I go over -1, and up 3. 0 means I just stay right here on the x, right? And I'm going to be on the y-axis, so I go up 1. 1, -1, 2, -3. And then I just connect that line. So there's linear ones. You could have done slope-intercept form, right? Just a little side note if you remember. The d of y equals mx plus b. So this was your y-intercept. This was your slope. So if you were to look at that, you could have made your y-intercept here at negative or at 1, right? Your slope was -2. So if you went down 2, down 2 and over 1, you'd end up here and you could graph it like that. It doesn't work so well to do slope-intercept form with absolute value because you start getting weird things happening. Does anybody remember what absolute value does or tells us? So if I said, what's the absolute value of negative 2? 2, right? It's telling me the distance from 0. So like if I look up there, negative 2 is 2 spaces away from 0. 2 is the same thing, right? You think about it a lot as making it positive, so it's really just the distance from 0. So when I go to plug these things in, something weird or something kind of different happens with these graphs. So if I plug in negative 2, Brendan just told us the absolute value of negative 2 is 2. And if I take 2 minus 4, I end up at negative 2. So I have my point there. All right, so I can keep that going. I'm going to plug in my x's in there. Keeping in mind that whatever's inside the absolute value, I'm just going to take the positive of that because I'm talking about distance from 0. So I'd have 1 minus 4, get negative 3. Then we take the absolute value of 0, you still get 0 because it's not anywhere from itself, right? So you'd end up with negative 4. And do the same thing. So absolute value graphs have this nice symmetry to them because if I look here, the absolute value of 1 and negative 1 is going to give me the same thing. So now I can look back up here and say, well, I've already done that problem, essentially. So I know that one's negative 3. The only thing that's changed is that my x value is the opposite sign. Same thing happens with 2, right? I've already done that problem up here. So I know that that is going to be negative 2, just my x value has changed. So now I can graph this just like I did on the last one, graphing my points. So if I go over 1, 2 to the negative, and then down 1, 2, I get my first point. And I keep that going, over 1, down 3. 0 was negative. So I'm down here. Once I get over to 1, I'm back down to negative 3, so I know that that's that point. And then 2 was negative 2 again. So anytime you have absolute values, these have a specific shape. They make that V-shaped graph. So when I make my line, I'm going to go up, basically up from the corner, right? Up from the point where I start to change direction again. So absolute values will always have that V-shaped graph. So the last graph we'll look at is what happens when I do like a squared. So this one, I would recommend typing into your calculator. When you do that, you want to make sure you put whatever the x is that you're squaring in parentheses. Right? Because if you type in negative 2 squared, actually let's negative 2 squared plus 1, I get 5. So I can put that, oops, no. Go away. Huh. Why won't you go away? So I knew this one was 5, right? Did I get what it was if I had plugged in negative 1 squared plus 1? Blank stares. What did we get for the y value for negative 1? What did you get? I saw you had yours filled out. What'd you get? 1, right? 1. 0 should be easy to figure out, right? 0 squared plus 1. No, not 1. So we figure out negative 1 squared plus 1 would give me 2. 0 squared plus 1 give me 1. And then I also, because, actually, let's just get rid of that. So because we're squaring and we get positive things too, this graph also has a symmetry to it. So 1 and -1 are going to have the same y value. 2 and -2 will also have the same y value. For which one? So -1 squared would give me 1. 1 plus 1 is 2. Okay. So then I can graph these the same way. All right, I go -2, 5. -1, 2, 0, 1. And then because I know I have that symmetry, I'm just going to go here. So the one difference between x squared and absolute value of x is I end up with more of a curve. Right, so I get that, what we call real quick on this. So we talk about continuous or discrete graphs and kind of situational stuff. So a continuous graph is a graph that is, we can think about it as unbroken. Right, it's one kind of continuous line. And then discrete ones are composed of, we'll call them distinct independent points. So discrete, we end up talking more about like, you can only have those number of points, right? You can't have something in the middle. So what a lot of the questions based on this stuff is just going to be looking at a situation and saying, is that going to be continuous or discrete? So if I'm talking the number of bagels in a shop depends on how many have sold. I want to think, is that going to be continuous or is that going to be discrete? So what I want to think about is like, am I going to sell like a third of a bagel or half of a bagel or a quarter of a bagel? Right, we might sell half a bagel, but then, so that one's kind of, in that gray area depending. But say, I sell a quarter of a bagel? No, right? I'm not going to cut a quarter of a bagel off to sell it. So because I'm not going to sell like the quarter, a third, whatever, this one I'm going to say is a discrete situation, right? There's going to be distinct points. Like if I sell one bagel, I'm going to have 99 left. If I sell two, I'm going to have 98. Kind of that. So another situation I look at is like, what about the amount of gas left in your tank depends on the amount of time driven. So let's say you have a full tank. When you drive, does it go from a full to like 3/4 right away? No, right? Can you have somewhere in the middle? Yeah. That, you watch your gas gauge, right? It's going to go down slowly, but it's never going to be like, oh, you can't have a quarter of a tank, right? You can. You could have an eighth of the tank. You can have, 2 miles left till you run out of gas, kind of a thing. So this one I'm going to call continuous.